Hi, in this video we'll discuss depth of processing and how it contributes to encoding or the transfer of information into long-term memory storage. Mere exposure to information, even repeated extensive exposure, may be insufficient to produce reliable memory for that information. For example, I'll give you a quick test. Which of these pennies, A through G, represents a correct illustration of the US penny? Take a moment to pick. Okay, the correct answer is C. Many have difficulty selecting the correct answer, despite the fact that they have been repeatedly exposed to US pennies throughout their life. The problem is that you lack intent to learn, so you'll likely process the stimulus on a very superficial level. Most people don't really scrutinize and memorize the features of the penny. For another example, check out the video in your slides about the US Post Office. Intent to learn matters because it influences the strategy that we use to encode information. In the vast majority of cases, elaborate encoding or deep processing is the best strategy for creating quality, accurate, and reliable memory. Elaborate rehearsal or encoding involves deep processing of information, thinking deeply about the meaning of information and how it relates to other pieces of information that you have stored in long-term memory. Compare that to maintenance rehearsal. This is a more shallow form of processing, thinking about information in a mechanical or repetitive way. In this particular study, researchers directly manipulated depth of processing. Participants were randomly assigned to one of three conditions that varied the depth of processing. In the shallow processing condition, they were simply asked to determine on each trial whether both words were printed in uppercase or lowercase typeface. In this condition, participants wouldn't even need to actually read the words to answer the question. In the medium processing condition, they would have to at least read the words because they were asked to decide if the two words presented on each trial rhymed. They would read the words, but just think about how they sounded. And finally, in the deep processing condition, they would have to think about the meaning of the word. In this condition, they were asked, are the two words synonyms? This required thinking about the meaning of the word. All participants were then given a memory recall test for the words they had seen in the previous trials. Those in the deep processing condition had better recall performance. Thinking about the meaning of the word helped memory. Depth of processing seemed to matter in terms of recall performance, but thinking about meaning is not the only way to deeply process information. Mental imagery also works well. You can mentally visualize information to engage in deep processing. Craig and Tolving showed that, presented participants with sentences that were either simple or complex. Each sentence had an underlying word that participants were asked to remember. Participants had better recall for words in the elaborate sentences like the great bird swooped down and carried off the struggling chicken. Chicken was the underlying word. They had better recall performance for that word when it was contained in this elaborate sentence compared to when it appeared in a simple sentence, such as, she cooked the chicken. And think about imagery here. How many of you, when you read the sentence, actually pictured a farm and a hawk swooping down and grabbing the chicken and its little legs flying around and it's trying to struggle away. That imagery that you created mentally is a form of elaborate encoding or deep processing that facilitates memory performance. In this particular study, participants were asked to engage in mental imagery or a more shallow form of processing, pronouncing the words backwards. Those who engaged in mental imagery had increased activity in the hippocampus during the learning phase, and that predicted greater recall performance during the time of testing. Why does deep processing or elaborate encoding create higher quality memories and enhance recall performance? It's likely that deep processing works because it helps to create multiple connections between the new information and existing memories or information that is already stored in long-term memory. We've talked a little bit about the network model of long-term memory. This idea states that information, memories are connected together via these complex networks in long-term memory storage. If new information is more deeply embedded into existing memory networks, then that memory should be more stable and easily accessed at the time of recall. When you learn information, you are creating retrieval paths. These are connections between the new information and already existing information in long-term memory. They serve as paths for retrieval at the time of recall, meaning that you can more easily access or retrieve and use this information at a later date, enhancing recall performance. You can think of it almost like a roadmap to that information. If you think about a town that has no roads leading to it, it would be pretty difficult to get to that town, right? The same could be for information that's stored in long-term memory. The more paths that lead to that information, the easier it is to retrieve it, and the better our memory performance for that particular piece of information. This directly relates to transfer appropriate processing or state-dependent learning, which we'll talk about in the next video.